Are we special? Mars might just hold the answer to one of the biggest questions plaguing philosophers, scientists, and late-night stoners since forever. Are we alone in the universe? Forget little green men for a second. Think microbes. Mars has an ancient geological record frozen, literally in time. Its rocks could preserve fossilized evidence of past microbial life. Finding even a single fossilized Martian microbe would be like discovering the Rosetta Stone of biology, proof that life isn't an earthly fluke, but a cosmic commonplace. It would revolutionize everything we know about biology, chemistry, and our place in the grand scheme. Mars is currently not habitable for humans and most known life forms due to several harsh environmental conditions. Here are the key reasons. 1. Thin atmosphere, low atmospheric pressure. Mars has a very thin atmosphere, composed mostly of carbon dioxide, CO, with a surface pressure about 0.6% of Earth's. This low pressure means liquid water cannot exist stably on the surface. It would either freeze or evaporate rapidly. The thin atmosphere also provides little protection from solar and cosmic radiation. 2. Extreme cold temperatures. Mars is much colder than Earth, with average temperatures around -60 degrees Celsius, -80 degrees Fahrenheit. Winter temperatures can drop to -125 degrees Celsius, -195 degrees Fahrenheit, near the poles. Such extreme cold makes survival without advanced heating systems impossible. 3. Lack of breathable oxygen. The Martian atmosphere is 96% CO, with only 0.16% oxygen compared to Earth's 21%. Humans would need spacesuits or enclosed habitats with oxygen generation to survive. 4. High radiation levels. Without a strong magnetic field and thick atmosphere, Mars is bombarded by solar ultraviolet UV radiation harmful to DNA, cosmic rays, high-energy particles from space. Long-term exposure increases cancer risks and damages electronics. 5. No liquid water on the surface. While Mars has ice caps, frozen CO and water, and possibly underground brine, there is no stable liquid water on the surface. Water is essential for life as we know it, and its absence makes agriculture and drinking water supply difficult. 6. Toxic soil regolith. Martian soil contains perchlorates, chlorine-based chemicals, which are toxic to humans and can contaminate water supplies. The dust is also fine and abrasive, posing risks to machinery and human lungs. 7. Weak gravity. 38% of Earth's. Mars has only 38% of Earth's gravity, which could lead to muscle atrophy, bone loss, and other health issues for long-term settlers. Could Mars ever be made habitable? Terraforming ideas. Scientists have proposed concepts to make Mars more Earth-like. Terraforming, but this would take centuries or millennia, thickening the atmosphere by releasing CO from polar ice, generating oxygen using plants or machines, creating artificial magnetic fields to block radiation, melting ice to produce liquid water. For now, any human presence on Mars would require sealed habitats with life support systems. Indeed, there are many challenges ahead. Sounds. Simple? Just mine asteroids or the moon for materials. No biggie. Manufacture unimaginably vast. Ultra-thin reflective films in space. Easy peasy. Assemble and deploy these structures with millimeter precision without them tearing, wrinkling, or drifting off course. Totally doable. The sheer audacity is breathtaking. The practicality? Let's just say the permits department is still laughing. Water recovery. Playing interplanetary plumber? Good news. Mars has water. Bad news. It's mostly locked up tighter than a miser's wallet. We've got the polar ice caps, mostly water ice under a dry ice topping, and subsurface permafrost discovered by probes like NASA's Mars Reconnaissance Orbiter. The northern cap alone holds enough ice to cover the planet in a global ocean 510 meters deep. If we could melt it all and stop it sublimating straight into the useless atmosphere, how do we get it? Proposals range from sensible to bonkers. Robotic ice miners, think giant. Automated drill rigs capable of boring hundreds of meters into the cryosphere, melting the ice and pumping it out. Basically setting up an off-world oil field, but for water. Dust, extreme cold, and potential equipment failures make this a maintenance nightmare light minutes from help. Atmospheric water vapor harvesters, like giant dehumidifiers for a planet. Inspired by devices used in Earth's driest deserts, these would suck trace water vapor from the Martian air. Efficiency is the problem. The air is drier than a British comedy. You'd need thousands of them running constantly for a trickle-directed energy. Zappers use microwaves or other focused energy to heat and melt subsurface ice deposits remotely. Sounds cool, but risks creating unstable melt zones or just vaporizing. The water we want. The bottom line, insider resource utilization, ISRU, is non-negotiable. Hauling enough water from Earth for a colony, let alone terraforming, would bankrupt every nation combined. We must become master Martian plumbers. The first colony's most valuable member might be the person who can fix the water extractor at 3 a.m. during a dust storm. Radiation protection, avoiding the cosmic sunburn that gives you cancer. This is the silent, invisible killer. Earth has two shields, a thick atmosphere and a powerful magnetic field. Mars has their cosmic rays, high-energy particles from distant supernova and solar particle events, which is basically the sun burping radiation directly at you, bombard the surface relentlessly. The average daily dose is approximately 0.67 millisieverts. That might not sound like much, but it adds up. Approximately 250 times Earth's background radiation annually. Long-term exposure means significantly increased cancer risks and potential neurological damage from particles zapping brain cells. Not ideal for raising families or maintaining sanity. How do we hide? Think like a mole person, lava tube living? Mars has huge, natural underground tunnels formed by ancient lava flows. These provide ready-made radiation shielding with meters of rock overhead. Building habitats inside them is a leading contender for early colonies. Pros: natural protection. Cons: living underground forever is kind of depressing. Also, finding stable tubes big enough near resources is tricky. Regolith. Bunkers bury habitats under several meters of Martian dirt. Regolith. Robots could pile it on top of prefab structures or use regolith to 3D print thick walls. Pros: uses local materials. Cons: excavating and moving that much dirt is energy intensive. Also, potential for leaks, collapses, and the feeling of living. In a tomb, water walls, using extracted water as a radiation shield within habitat walls. Water is excellent at blocking radiation. Pros: dual-purpose resource. Cons: requires massive amounts of water. A leak isn't just messy, it's a loss of precious shielding. Also, freezing is a problem. The sci-fi option, magnetic force fields. Create an artificial magnetosphere. Ideas include placing a giant superconducting magnet at the Mars-Sun Lagrange point, L1, to deflect solar wind before it arrives, or generating local magnetic fields over settlements. Pros: would be awesome. Cons: requires technology that currently exists only in physics papers and comic books. The power requirements alone are ludicrous. The radiation problem is arguably the most immediate and serious for human settlers. Forget breathing, you can live in a suit. You can't live inside a particle accelerator beam long term. Early Martians will likely spend most of their time huddled underground or behind thick walls, venturing to the surface only for essential, heavily shielded tasks. It puts a damper on the whole wide-open Martian vistas. Tourism pitch. Chapter 4, Becoming Martians. Evolution and fast-forward, sort of, over generations. Martian settlers will change. Biological tweaks. Living in 38% Earth gravity will have effects. First-generation settlers will exercise like maniacs to combat bone and muscle loss. But their kids, born and raised in Logi, they'll likely be taller and thinner, less gravity pulling them down, but also have less dense bones and weaker muscles. Naturally, After several generations, these could become fixed traits. Circulation might adapt. Even childbirth could be different. Lower gravity might make it easier physically, but the long-term effects on development are unknown. Some evolutionary biologists speculate that with enough time and reproductive isolation, i.e., minimal influx from Earth, Martians could become a distinct subspecies. Homo sapiens martianus, or eventually, if genetic drift is significant enough, a whole new species. Don't expect green skin and antennae, though. Think more .. cultural speciation. This will happen much faster than biological changes. Martian culture will diverge rapidly. Their values, priorities, sense of humor, gallows humor will be strong, relationship with Earth, those resource-hogging, gravity-slug Earthers, and even language incorporating technical jargon and new slang will become distinct. They'll develop their own myths. Heroes, the first person to fix the broken water recycler during the Great Dust Storm of '72, and eventually a Martian identity. This almost inevitably leads to independence, just as the American colonies grew apart from Britain. A thriving, self-sufficient Martian society will eventually ask, why are we sending our resources back to Earth? Why do we follow their laws? Political independence movements seem inevitable. Will it be a peaceful secession or an interplanetary war fought with drones and orbital mechanics? History suggests the latter is depressingly plausible. The Martian Revolutionary War has a certain ring to it, doesn't it? Conclusion. Mars is our mirror, crucible. Our fixation with Mars is a funhouse mirror reflecting humanity. It shows our boundless curiosity, our knack for seeing patterns, even imaginary canals. Our terrifying capacity for self-destruction, hence needing a backup planet, and our audacious engineering dreams, orbital mirrors. Seriously, the technical challenges brutally expose the limits of our current know-how. The philosophical questions force us to confront our deepest assumptions. Are we stewards or conquerors? Are we special or just lucky mold? What does survival really mean? Mars isn't just a destination, it's the ultimate crucible. How we approach it, with cooperation or greed, with humility or hubris, with respect or rapaciousness, will reveal who we truly are and define what we become. Will we be wise enough to avoid repeating Earth's mistakes on a pristine world? Bold enough to take the leap despite the insane risks? Patient enough to commit to a project spanning generations? Will never meet? The red planet hangs there, silent and dusty, waiting. It doesn't care about our dreams or our fears. It just is the challenge, the test, the potential future. It's all ours to grasp or fumble. One thing's certain, getting there will be the hardest thing we've ever done, making it a home. That might just be impossible. But since when has impossible ever stopped us? After all, we're the species that looked at a weird red dot in the sky and thought, I bet we could live there ... probably. Onward, weirdos, the dust awaits. Bring extra air filters. And maybe a sense of humor. You'll need it.